that you have doubt in?
Yes, sir. At 127 Kelvin and 1 atmospheric pressure, the gaseous mixture of carbon CO and CO2 is in equilibrium with solid carbon has 90.55% CO by mass. Calculate the equilibrium constant for this reaction at the above temperature.
Okay, so what the other gas is CO2, no?
Yes, sir.
The other gas is CO2. So 1 atm pressure, and there is, what is the reaction you're seeing? Carbon solid plus carbon
CO2.
dioxide gas. It is giving me carbon monoxide gas, right?
Yes, sir.
Okay, fine. So see how this question, yeah, I understand. Yeah, this question is a bit lengthy. I mean, you need to know what things you have to do in this question. It's not very straightforward. It's not very straightforward. So first of all, what I will do, I will calculate the mass of CO2. I will calculate the mass of CO2. So we have a gas mixture. In that gas mixture, they are saying that 90.
Sir, can you repeat the question?
The question is question number 23, na? Mariam?
Yes, sir.
Question number 23. Okay. Now, in this question, what you have to do, you have to start with gas mixture. So we will say let the mass of gas mixture is 100 grams. Okay. Now from here, what you can say, mass of carbon monoxide, it will be equal to 90.55 grams. And mass of carbon dioxide, this will be equal to how much? 9.45 grams. Okay. Till here, any doubt, Mariam? You tell me.
Sir, where did we get the grams from?
Yahi to bol. So you remember we had this type of question in stoichiometry, the first chapter. Yes or no? You don't remember that?
No,
Have you done stoichiometry, the first chapter with me, or no? You
yes,
have
sir.
done first chapter. You have done the first chapter with me.
Yes, sir.
So in first chapter we had many things, na? Like whenever there was percentage given, what we used to do. Chapter 1 में ज़्यादा इसमें किया नहीं, लेकिन हमें लगता है. Wait a second. No, this is the last class. See, we start with assuming that it is completely 100%, right? Now, mass percentage is given. Okay, then from mass percentage, we calculate, first of all, what? These are grams. Now, when we calculated grams, then we calculated the mole ratio. So, you remember this, yes or no?
Yes, sir.
है ना? So, जैसे वहां पे हम लोगों ने 100 ग्राम ले लिया ना, let the mass of mixture is, because they have given percentage, we can take any mass, right? We can take any mass. We are more concerned about the percentage here. The percentage should be correct. So now you have this mass of CO2. Now from these masses, what I will do, I have mass of carbon monoxide and I have the mass of carbon dioxide. Okay. So what I will do, I can, from both of these, I can calculate the number of moles. Yes or no? Tell me. Can I calculate
Yes.
number of moles? Okay. Achha, from this number of moles, can I calculate the mole fraction for each of them? Tell me.
Yes, sir.
I can calculate the mole fraction for each of them. That means this will be chi of monoxide and this will be chi of dioxide. Okay. Now I have the P total. P total, it is equal to 1 atm. Now from partial pressure, sorry, I can calculate the partial pressure of carbon monoxide as the P total into the mole fraction of carbon monoxide, and the partial pressure of CO2, it will be equal to the P total into the mole fraction of CO2. Yes or no?
Yes, sir.
Hana? Dalton's law of partial pressure. Now what you have, Kp. So Kp, this will be equal to what? What is the product here? The product is carbon monoxide. No? So I will write the partial pressure of carbon monoxide. square divided by the partial pressure of carbon dioxide. I will not take carbon solid because it is in solid state and the concentration will be 1 and the concentration will be 1. So you can calculate Kp from here. Then you know
Yes,
that
sir.
the relationship that Kp is equal to Kc into RT delta Ng. Okay. I know, I understand it is very long. It's very long. It's going to be very long because you have to calculate moles and mole fraction, then the partial pressure. Then again, you have to calculate the Kp. From Kp, you have to calculate the KCRT, and it's not going to be very easy because you have to do here R. And what will be R here? 0.0821. Okay, 0.0821. Why? Because we have been given in ATM, right? The pressure is given in ATM. The temperature they have also given how much? 1127, no? 1127, right? They have given the temperature 1127. You can calculate the delta Ng from the reaction, right? You can calculate from the reaction, and you have the Kp. You can calculate the Kc also. Okay.
Yes, sir.
So I understand this was a bit tricky. If you understand this part, then only please, whenever you get percentage now, try to think that you can take 100 grams. Okay, this is one tool that you can keep in your mind, and you can always remind yourself that I can take 100 grams. I can take any easy case if I have been given a percentage. Okay. Now, so moving on to last class, we ended at effect of temperature, effect of concentration, effect of temperature.
Note.
You want notes? Okay, sorry. Okay, this will be what? Equilibrium. I don't know which part this will be. What was the date? It was Monday, 17 Jan. Equilibrium on 17 Jan. It is getting uploaded, Reba. Okay.
Yes, sir.
Okay. So we have done two: effect of change in concentration, effect of change in temperature. Now let us write the next part. Effect of pressure. Effect of pressure. Now let us start with a simple reaction. If I will have N2 gas plus H2, it is in equilibrium with 2 moles of NH3. Okay, 2 moles of NH3. Now think what will happen if I will increase the pressure. What will happen if I will increase the pressure? Whether the reaction it will move more towards forward direction or backward direction. What will happen if I will increase the pressure? Okay, let me make it simple for you. Okay, let me make it simple for you. If I will increase the pressure, then association will increase or dissociation will increase. What will happen? Will more things combine or more things will get dissociated? If I will increase the pressure, what will happen, guys? Tell me. Yes, Atif, Mariam,
Things will
yeah.
get
Mariam?
associated.
Yeah, the associations will increase, right? Because if I'm increasing the pressure, the combination, the two things will combine more efficient. Two things will combine more efficiently. So can I not say that if I will increase the pressure, more and more NH3 will be formed, and what will happen? the reaction, it will go towards forward direction. The equilibrium will shift towards forward direction. Yes or no?
Yes, sir.
Okay. Now thinking about in terms of the Lee-Chattier principle, it states that whatever change or disturbance that you bring about in an equilibrium system, the system will move in the direction where the equilibrium will move towards the direction where the change is minimized, So what it wants to do, if you have increased the pressure, it wants to decrease the pressure. And to decrease the pressure, it has to move towards our side. It has to move towards a direction in which the gases are the number of gases are less. The number of moles of gases are less. That means obviously it is going to move in the forward direction in this particular example. Okay, so you can write since, or rather on increasing pressure, the system will yes, Atif, yes. Okay. On increasing the pressure, the system will shift the equilibrium towards that direction which has less number of moles of gases. Okay, which has less number of moles of gases. Similarly, on decreasing the pressure, the system will shift the equilibrium towards that direction which has more number of moles of gases. Right, next point. If in a chemical reaction, the number of moles of gases in reactants and products are equal, then the change in pressure will have no effect. Write this down, let me know if you're done.
Done, sir.
Done, all of you? Is there anyone who's writing? Okay, fine. Write a question.
Done, sir.
Which of the following will have, wait a second, no, okay. What will be the effect of increase in pressure in following reactions? Right, number A. Write number B. So these all are gases, okay? Let me also write the phases. Please keep in mind that it should be a balanced chemical reaction. So for these three, I'm increasing the pressure, okay? So you have to tell me what will be the effect. Whether there will be, the equilibrium will change toward forward direction, backward direction, or no effect. Three options, you have only three options. Yes. Yes, guys, tell me in chat at least. Atif, you tell me for the A question now. Atif, turn the mic on and tell me for the A question. What will happen if I increase the pressure?
So it will go backward.
It will go. If I will increase the pressure, what it will happen?
So the reaction will go backward.
Backwards. If it is going backward, where is the number of moles is higher, in the reactant or the product? Where is the number of moles higher?
Reactant, sir. Reactant.
If I'm increasing the pressure, you are saying that what will happen? It will go forward, then it will make more moles of gases, and then the pressure will again increase. See what I have written now. I'm
So they
increasing the
said
pressure.
backward.
A backward reaction, what does it mean? It means that it will form NO2, na?
Yeah.
So if it is going backward, then it is forming more moles of gas or less moles of gas? जी बताइए.
Forward, sir. Forward.
क्या हो गया आपको? Yes, Riba, correct. So here it will be going forward direction. Yes, Aisha, you tell me for the B1. Yes, Aisha. बहुत लेट आई हैं आज आप रिहाब. You are very late, huh? Yes, Rihab, what happened? You are not audible, Emma. Okay. Okay, Aisha is not here. Oh, fine. Muhammad Umar, you tell me for the B, forward or backward? Yes, Muhammad Umar. No answer. Guys, if you don't speak, okay, fine. Somebody please tell me. For the B1, what will be the change? Yes, Reba.
Backwards.
Backwards. Why backwards? Where there is more number of moles of gases? Tell me, Reba, in reactant or product?
In product.
In product, we have more moles of gases. How many moles?
2 moles.
In the reactant?
1 plus 1.
1. Is it 2 है ना? 1 mole of H2 and
sir.
1 mole of I2.
Yes, sir.
So there is equal number of
Nothing
moles.
happened.
That's why no change, hai na?
Yes, sir.
No change. What about the C? Wrong answer, Aisha. What about the C? C question.
Backwards.
Backward क्यों जाएगा? अच्छा, you tell me where there is no more number of moles of gases. How many moles of gases are here? Yes, Reba.
3.
3 moles नहीं, carbon तो solid है ना?
Yes, sir.
2 ना? And what about here?
1.
1. So if I am increasing the pressure, where will the equilibrium shift?
Forward.
Forward, है ना?
Yes, sir.
Okay. चलिए. Right, next, effect of volume. Effect of change in volume. Since increase in volume leads to decrease in pressure and vice versa, hence what will happen? Change in volume has inverse effect of change in pressure, of change in pressure. So you can write, so if volume is decreasing or increasing, if volume is increasing, then what is happening? The pressure will be decreasing. If the volume is increasing, pressure will be decreasing. So it will shift towards more number of moles, shift towards of moles. Now, if I will decrease the volume, the pressure will increase. And if the pressure is increasing, then it shifts towards less number of moles. Write this much, let me know if you're done.
Done, sir.
Okay. Is there anyone who is writing?
So I'm writing.
Okay.
Sir, what questions did you ask us to do in the previous class?
क्या रिबा आपने क्या कहा?
Sir, you gave some questions in the previous class. What are they, sir?
So questions, they are NCERT exercise 7.8 to 7.23.
Okay, sir.
Yes, Mohammed Umar, done?
Yes, sir, done.
Right, next. Effect of addition of inert gas. Effect of addition of inert gas. Okay. If we are adding any inert gas in a reaction, that means a gas which is not reacting, then it will occupy volume, right? So it can do two things depending on the condition that we are providing. So if we have, if we keep the volume constant, if I keep the volume constant, that means I am adding, and the reaction, it is happening in a closed vessel. Okay. So the word that you are looking here is closed vessel. Sometimes you will have in a closed vessel, if I'm adding inert gas, then what will be the change? So you will take the case of volume constant. If the volume is constant, and if I have a box like this, in which there are some reactants and there are some products, the reaction is already happening, and we have some, okay, we have different gases here, right? We have different gases. Now the equilibrium has been maintained, but in this closed vessel, I'm adding more number of moles of gases. Okay, I'm adding what? Adding inert gas. I'm adding inert gas. Just wait a second. Okay, just wait a second. Sorry for that. So volume is constant in closed vessel. If I add inert gas, then what is going to happen? The pressure is going to increase, right? Because I'm adding more number of moles of gases. Now pressure will increase, right? Now if pressure is increasing, what will happen? The equilibrium will shift towards less moles of gas. Okay, in a direction towards less moles of gas. Now, if I will add an inert gas with keeping the pressure constant, so there is no change in pressure going on. So you will be given that the pressure is not changed, the pressure is constant. You will not be, there will be not in question flexible vessel or something. Okay. So what is going to happen if if the pressure is constant, then this inert gas, as soon as it is added in a system, since the pressure is constant, volume is not constant, it can expand. Now, if it is expanding, it is increasing the volume. It will increase the volume. So in this case, what is happening? If I will add on addition of inert gas, the volume increases. The volume increases, right? Now, what is the effect of volume increase? There will be a shift towards
More moles.
more moles of gas. Very good. More moles of gas. Please write this down. Let me know if you're done.
Done, sir.
Okay. Let me know if all of you are done. Is there anyone who's still writing?
Sure.
Okay, so you have to describe the effect on the equilibrium of on the equilibrium reaction. You have 2H2 gas plus carbon monoxide gas. It is in equilibrium with CH3 OH, which is also a gas. Okay. So you write this down. I'm waiting for your answers in the chat. All of you understand the question now. If you have doubts or somewhere, or if you don't understand where to start from, then please let me know.
So what are we
So
supposed to
please-
say?
No, in the chat. No, but you can say if you have a doubt. Yeah, you have a doubt,
Sir,
Deepa? हाँ बोलिए मरियम बोलिए.
sir, how do we start doing this question?
How do we start doing this question? But we have done this now. Like you have done the theory part, yes or no? Yes, Mariam. In the last class we discussed now these. Yes or no?
Yes, sir. Yes, sir.
So like there are two things. Like you can go to the completely first principle way of thinking, or you can maybe, if you remember what is the effect of adding reactant and adding product, so you can use those also. So if you want me to start with the very basic and the first principle concept, then I will say that when we have an equilibrium, the system, it wants to sustain the equilibrium. So whatever change I'm going to do to disturb the equilibrium, whatever change, if I'm adding a reactant, then I'm disturbing the equilibrium, because the concentration of reactant has increased, and as soon as the concentration of reactant has increased, that means I have disturbed the equilibrium. So what will happen to maintain the equilibrium? The reactant, whatever I have added, will be consumed to form product. Yes or no? You understand this? Yes or no? Tell me.
Yes, sir.
So Reba, what about you? आप नहीं थी last class में. आप समझ पाएंगे whatever I said? Did you understand?
No, sir.
नहीं कुछ नहीं समझ पाया आपको. Okay, fine. आप you were in the आज कितनी क्लास में हुई हैं आपकी?
Like, sir, I was there Wednesday की class.
Last Wednesday you were there.
Yes, sir.
So last Wednesday did we start chemical equilibrium? कितना क्या था?
Yes, sir. We wrote a few pages.
हाँ, characteristics of equilibrium, forward reaction. Okay. So अच्छा, आप ये forward reaction, backward reaction के बारे में बता सकती हैं कि नहीं बता सकती? ये बताइए आप.
Yes, sir.
You tell me. अच्छा, you know this ना, predicting the direction of reaction इस class में थी ना आप?
Yes, sir.
Okay, so if I will give you a situation, you can tell me na whether it is going to be forward direction or backward direction.
Yes, sir.
Okay, fine. So I am telling you. So keep your mic on. So you have the reaction in which hydrogen is reacting with carbon monoxide to form methanol. The equilibrium is maintained. The equilibrium has been achieved. Okay, Reba?
Yes.
Okay. So we will have an equilibrium constant. Yes or no?
Yes, sir.
Okay. That means the concentration of product and reactants, it is what? It is now equal. Okay. The concentration of reactant, not equal. They are constant now. The concentration of reactant and the concentration of product, it is equal now. Okay. Again, I'm saying equal. I'm really sorry. It is constant now. Okay. And we have an equilibrium constant. Achha, what will happen if I increase the amount of reactant? What is going to happen? Tell me. Reaction will move forward or backward? I can't hear you, Reba. I can't hear you.
Yes, sir.
I asked you. हाँ बताइए.
Sir, can you repeat what you asked?
You
Your
did not
voice was
hear what I asked.
breaking, sir.
Achha, my audio was breaking. Okay, fine. I'm saying what will happen if I increase the concentration of reactant? The reaction will move forward or backward?
Forward.
Forward. What will happen if I increase the amount of product? The reaction will move
Backward.
forward. Anna, if I will increase the product, it will move backward.
Yes,
Okay.
sir.
Now you tell me if I'm adding H2, what I am doing?
You're increasing the number of reactants.
So the reaction will go forward. है ना? बात हो गया
Yes,
आपको?
sir.
है ना? अब कर
So
लीजिएगा सारा.
this, sir,
Sorry.
we just have to say if it's forward or backward.
हाँ, बस describe the effect. ना? It
Okay.
will going forward
Okay,
or
sir.
back. Okay, Mariam. Okay. अरे Mariam, can you please turn the mic on?
Yes, sir.
अब ये बताइए, like for the C1, okay, what am I doing? Tell me.
Removing CO,
So what I'm doing? I'm removing reactant or product?
reactant.
I'm removing reactant. So what will happen? Now comparatively, the amount of product is higher, no? See, Mariam, listen here.
Yes, sir.
This K has to be maintained. Okay, K has to be maintained. So what I have done, let me write product here, let me write reactant here. What I have done, I have removed CO. That means I have decreased the R. Yes,
Yes, sir.
right? So what I have to do, I have to increase this R na, to make it constant.
Yes, sir.
So what will happen?
Move backward.
Started backward, है ना?
Yes, sir.
If I'm removing something, it means what I'm in. If I'm removing product, that means I can say that I'm increasing the. If I'm removing reactant, that means I'm increasing the product. भाई साहब इतने सारे मैसेज आ जाते हैं बिल्कुल साथ साथ. अच्छा, ओके ओके. रीबा, आतिफ, फाइन फाइन फाइन. Atif has answered all the questions. Okay. Constant. Volume will increase. So if volume increases. Okay. Yes, correct, correct. Yes, Atif, I think all of your answers are correct. So those who have not done till now, they can. So in addition of H2, it will move forward. Addition of CH3OH, it will move backward. Removal of CO, it will move backward. Because I'm removing CO, I need more CO to maintain the equilibrium. Removal of CH3OH, it will move forward. Now, addition of helium at 1 atm. So if I'm adding helium at a constant pressure, then the volume will increase. If volume will increase, it will move towards more moles, more gas. That means it will move backward. And here we have more number of moles of gas. Now, if I add helium at constant volume, it means the pressure will increase. That means it will move towards less gas. And that means it will move forward. Okay, guys? Any problem?
Can you explain?
I can't hear you, Muhammad Umar. Can you please repeat? What did you say?
So can you explain deep? Option
D.
D. Yes.
Option D. Okay. So I am removing CH3OH. I am removing CH3OH. What do I have? H2 and CO. H2 plus CO. It's in equilibrium with CH3OH. Now equilibrium has been maintained. Equilibrium has been maintained. So it needed a certain amount of CH3OH and certain amount of hydrogen and CO. So let us say that it needed P amount of product and it needed R amount of reactant. Okay, Muhammad Umar, to maintain the equilibrium.
Okay.
Fine. Now what I'm saying, I removed. So I decreased the P. Hana?
Yes.
Now equilibrium, what can the system do? System can either move forward or it can move backward. Hana? It can. System is not a human being. System is system. It is a non-living thing. It cannot remove or it cannot add something to itself. Hana? So it has to just move forward or backward. Okay, it can just swing here and there. So you can't say if I have removed the product, then you cannot remove the reactant. What you can do is you can convert the reactant to product. Yes or no?
Yes.
To maintain. Yes, Muhammad Umar.
Yes. Yes.
Got it?
Yes. Okay. I got it.
Okay. So you have to maintain the equilibrium. Okay. You have to maintain. See, a human can remove and human can do some changes, but the system, what it will do, it has to maintain equilibrium either by moving forward or backward. Okay. Only it can do only two things, either move forward or backward. Okay. So lastly,
Sir, can you scroll up?
Scroll up. Okay.
Okay, sir. Done.
Done. Right, next that we have already written once, effect of catalyst. Effect of catalyst. What is the effect of catalyst? Catalyst has no effect. Has no effect on the state of equilibrium. On the state of equilibrium. Okay, so at this point, chemical equilibrium is completed. There is one more portion in equilibrium, that is the ionic equilibrium, that we'll be starting now. Okay, we will be starting ionic equilibrium now. So write the last thing, that is the effect of catalyst. Catalyst has no effect on the state of equilibrium. Then you can write the heading. Ionic equilibrium. Ionic equilibrium. Okay. So in ionic equilibrium, first of all, let us say how this field came into being. The main point and the starting point of this was Michael Faraday, and I will not go into the sets of experiment that led to this field of ionic equilibrium. I can just give you guys an idea about sodium chloride, that is the stable salt. Now NaCl, when it is in solid state, it was seen that it is a non-conductor of electricity. Okay, it doesn't conduct electricity. Okay, but when I added NaCl into a pure water, so pure water does not conduct electricity, but as soon as I added something which does not conduct electricity into something which does not conduct electricity, okay, so I have two things here. Now this is, I mean, for now us, For us, it is very easy to see, and it is like, हाँ ऐसा तो होता होगा, क्या हो गया? But imagine the state of those person who discovered these things. So you had, this is NaCl, which does not conduct electricity. This is water, H2O. It also does not conduct electricity. Doesn't conduct electricity. But when you added both of these things, NaCl into water, if I had added NaCl, this has NaCl in this. Now this water, it is going to conduct electricity. So just think about it and try to imagine what would have been the state of person who discovered this, that if I take something which is not a conductor of electricity and the other thing is also not a conductor of electricity, but when I add both of these things, they start conducting electricity. Okay. Now, since they are conducting electricity, it means that what they are having, they are carrying charges. So there should be something which we can call as charge carriers, Now, looking at NaCl, it was very obvious that what would have happened is sodium chloride, it would have, when we added water to sodium chloride, then it would have been forming Na plus in water, that means in aqueous, and Cl negative also in the aqueous phase. Now we have these two charges, Na plus and Cl negative. These are charges, and when they flow, and by the virtue of this flow, by the virtue of the movement of these ions, the electricity is also flowing. Okay, so this was the first step towards the field of ionic equilibrium. Now, one more thing that I want to tell you guys is that in ionic equilibrium, it is not different with the chemical equilibrium that we have studied. Okay, so in chemical equilibrium, we had three things. We had initial, okay, we had change, and then we got to equilibrium. Now, let me also tell you guys, I did not tell you, why do we learn this equilibrium chapter? Why do we calculate the equilibrium concentration? Those who did the question, Mariam, you did many questions now?
Yes, sir.
All of the question, it was somewhere around calculate the equilibrium concentration, calculate the pressure, partial pressure at equilibrium. Yes or no?
Yes, sir.
It was something like this. Okay. So why do we need to calculate this? It was tough, yes or no, Mariam? Quadratic equations aake?
Yes, sir.
Very lengthy, hai? But let us also appreciate now, why are we doing these lengthy calculations? What do we need? We had initially, before equilibrium, we had simple things. We had A plus B giving me C. But now in equilibrium, we saw that I can have A, I can have B, and when I add these two things into a particular container and they start reacting, after some point of time, I am getting A, B, and C. I'm getting some moles of A, I'm getting some moles of B, and I'm also getting some moles of C. Long time, the equilibrium has been achieved. The concentrations are not even changing now for C. Okay, they are not even changing for C. Now this led to a question. How much is the concentration of A, B, and C? Now there were two ways of tackling this. For example, if I talk about the initial, that is reactants, we have A, that is separate. We have B, that is another in some container separate. We will take the bottle of A or the container of A and container of B. Then we will move to something which can measure weight. Okay, a device which can measure weight. Then we will take some grams. Let us say some X grams of A. We will take Y grams of B. then what we will do to calculate the concentration, I will convert this into moles and then divide by the volume. So what is the device I needed? What is the device I needed? So it is very important to keep in mind the economy of the reaction. Economy means what are the things that you need. You don't only need A and B to do a reaction, you also need something that can measure the weight of A and measure the weight of B, and then only you can do the reaction. That means I need some device that measures weight. Is it easily available or it is very difficult to avail? Tell me. A device which can measure weight, easily available or not? Arey, what happened?
Easily available, sir.
Easily available. To calculate the volume, what do I need? I need 3 lengths, right? I need the length, breadth, and height. That means I need just the lengths. Okay, so for length, you can use a ruler, right? You can use a ruler. A device which can measure length, it is also very easily available. So for the initial concentration, if I wanted to have the information of initial concentration, it was very easy for me. It was very easy for me that I can just take some A, measure the weight, measure the volume, divide them, and get the concentration. But when I achieved equilibrium, and in that I had ABC in a mixture, then what I had to do, I had to first separate them. Now for separating these, depending on what do we have, what is the nature of the substance that we have in equilibrium, depending on that, we have to choose different devices. And now you tell me, at this point of time in 11th standard, do you know of anything that can be used for separation of chemicals? The whole chemical, yeah, I want to calculate the concentration. Now, I don't want to detect things. I know you know salt analysis. You can tell me which salt is present, but I want to know what is the amount of a particular substance in a mixture. Is it as easy or is it as easy as measuring weight? Tell me, yes or no. Is it as easy as measuring weight? Do we have any device? No, it is, we don't have any device. Okay. Now, when we don't have device, I don't know whether I have told you this earlier or not. There is only 2 things that we can do to quantify something. We can either measure it or I can calculate it. Now, when the measurement was very expensive, we went for calculation. Now, Mariam, you tell me, depending on the choice, what is more easy, calculation or measurement?
Calculation.
Now quadratic equation seems okay. Yes, Mariam?
Maybe.
Maybe. Okay, fine. Yeah, it is obviously it is tough for you. But again, you have to appreciate whatever science you are learning. It is not like in science people give you tough things. Okay, so why it feels like science it is tough and things that you do in science is tough? Because we don't see the alternative that we have. What was the alternative for us? First of all, we needed to extract all of these things, A, B, and C. Then we had to measure them, the weights, and then we had to calculate the concentration. Now, just imagine how much error would we get if I was extracting something and it did. I cannot extract the whole thing completely. Some of the particles were left there. So those are the things that is difficult. Those are the things that is difficult. Now, calculation, you just think, what do I need for calculation? I need some background in chemistry. And I just need a pen and a paper and a working brain. So comparatively speaking, if I'm not evaluating the value or the price of a working brain, but still it is for us, monetarily speaking, it is less expensive, right, to calculate rather than to measure. Okay. That is why we calculate and we don't measure the equilibrium concentration. Now, in this case of ionic equilibrium, so let us go back to the chemical equilibrium. We had same thing, initial, then we had the change, and we had the equilibrium. Now, the main thing of equilibrium was to calculate the equilibrium concentration. And those are the questions, those are the real questions. If somebody is asking you to calculate the equilibrium constant, then please remember that is not a real question. Okay, that is not a real question, because if you have the concentration, then only you can calculate the equilibrium constant, right? You can calculate the equilibrium constant. Now, equilibrium constant, it can be easily It can be easily accessed if you have a internet. You can just Google for a reaction, what is the equilibrium constants. But if there is a question, they are asking what is the equilibrium concentration, then it is a good question. The other thing that you can be asked for gases is the partial pressure of each gases at equilibrium, right? The pressure. Now, for this equilibrium, we also had some things in our data. We can say that Kc and Kp, they can be easily accessed in the internet. That means I have, for all of the reaction, I have the Kc and the Kp. Initial, that is something that the questioner will give. That means I have to pay. For change, I will refer to reaction. I will refer to the reaction that I have. And according to the reaction, I will do minus x or minus 2x or plus 2x or plus x or something else. Okay. So I will refer to the reaction. So initial, that I have to take. Okay. You don't worry about the initial, because I am the one who is doing the experiment. I am going to take the initial concentration. I am going to give you the initial concentration. But and internet is going to give you the Kc and Kp. Internet means you will be given Kc and Kp. Okay. I'm talking about in the sense of how real science happens. So in the internet, you will get Kc and Kp. Change you will get from refer to the reaction. You have to calculate the equilibrium concentration and the P. Now I know by using initial and change, I can form an equation for Kc and Kp. And from Kc and Kp, I can go to the concentration. I can also calculate the concentration. Now, if I have pressure involved, then you also know that P total, it is equal to the P1 plus P2 plus P3. Now, it will be giving you something about the equilibrium. It can also give you the P total. And from P total and initial and change, what you can calculate? You can calculate the partial pressure of initial gas, different gases. So in this case, you saw that I had Kc and Kp. Now in ionic equilibrium, we will be introducing another K. Okay, we'll be introducing another K that will be helpful in calculating the concentration at equilibrium. The concentration at equilibrium. Okay, so the whole point of ionic equilibrium is just that if I have ions involved, then there is some different K that is used. We will introduce that K, and then we will go on doing the question. But again, I have to start with all the things that are there in your syllabus. Now, in the face of ionic equilibrium, in the umbrella of ionic equilibrium, NCERT has involved many topics. One of those topics are electrolytes, strong electrolytes, weak electrolytes, the concepts of acids and bases, Harhenius, Bronsted-Lowry, Lewis, their limitations, and many things like that. So whatever we are going to learn now is not going to directly, help in this initial change and equilibrium criteria that we had. But these things are also important, okay? But they will be asked in your examination. Why we are learning this? Because it will be asked in your examination. Now let us move on to writing what is an electrolyte. So as I said, NaCl, it does not conduct electricity, but in aqueous state, or if you liquefy it in molten state, it will conduct electricity. Now these type of substances are known as electrolyte. So the first thing that you will write is the substances. Please write with me. The substances which conduct electricity in their molten state, or in aqueous phase, are called electrolytes. For example, NaCl, that is solid. If I will add to it, will add water to NaCl, and it is going to become Na plus aqueous plus Cl negative aqueous. So I can see that what is happening. Now these are the charges which carry the electricity in aqueous NaCl. Now if I add electrolyte on water, when electrolyte is added, electrolyte is added in water, it splits up into its ions. And now this splitting is known as dissociation, or it is also known as that they get ionized. Okay, they get ionized. But please remember that it is not the ionization that we have talked about when we were talking about the ionization enthalpy. Okay, we may use the word ionization and dissociation very what I can say interchangeably, but please remember it is not the ionization as ionization enthalpy. It is just that two things are getting dissociated. Okay, so you can write depending on the extent of dissociation, depending on the extent of dissociation, electrolytes are divided into two types. Number one, strong electrolyte. Okay, strong electrolyte. Now, strong electrolyte, they completely dissociate into ions. They completely dissociate into ions. Some of the examples will be if you have very strong acids and bases now, and salts of strong acid and base, they are what? They are strong electrolytes. For example, you have HCl, H2SO4, HNO3. For bases, you can write NaOH, KOH. For salts, you can write NaCl, KNO3, etc. Now, since they completely ionize or dissociate, I can write that HCl plus water, a double-headed arrow, simple like this, and it is going to give me H3O plus chlorine negative. Now, in terms of equilibrium, what does it means? That it means that on adding HCl to water, at equilibrium. At equilibrium means after a very long time. At equilibrium means after a very long time also, when all the H plus or whatever was happening, whatever the change was happening, the change has been stopped. We don't see any considerable change happening. At point of time, if I've added HCl to water at equilibrium, none of HCl would remain unionized. Okay, that means all of the HCl would be converted to Cl negative, and the H plus would have been converted to, from HCl, we have two things, H plus and Cl negative. So the Cl negative will be Cl negative, H plus would have been converted to H3O plus. Okay, that means you will not get any HCl at equilibrium if you have a strong electrolyte. Okay, this is important. Next is weak electrolyte. Weak electrolytes. You can see here that the extent of dissociation is small. Extent of dissociation is small. Some of the examples will be organic acids such as CH3, COOH, acetic acid or ethanoic acid, NH4OH, or NH4 whole twice, CO3. Next is HCN, NH3. Okay, so all of these are examples of weak electrolyte. Now, in this, what will happen if I will have CH3, COOH, and I will add this to water? Then at equilibrium, I will be having some amount of CH3OH and some amount of CH3COO negative. CH3 will be converted to CH3COO negative plus H3O plus. So it means that if I have a weak electrolyte, then at equilibrium, there will be some unionized weak electrolyte. Okay, unionized molecules of weak electrolyte. So it means that at equilibrium, rather I should say when weak electrolyte, when is added to water, then what will happen? Then some unionized molecules of weak electrolyte remains in solution at equilibrium 2. At equilibrium, that means there will be some amount of CH3COOH that will be always present in the solution. Write this down. Let me know if you're done.
Done, sir.
Okay. Is there anyone who is still writing?
I'm right.
Okay. Surat, how is the cold in Delhi? Kuch kam hua ya fir after the rain it has increased?
Sir, it didn't rain at my place.
It did not. कुछ दिन पहले तो हुआ था. I think like a week back. No. अच्छा, आपके यहाँ नहीं हुआ होगा. But at some part of Delhi, I came to know that it rained. Like my relatives, they live there. Some friends also. Yes, guys, done. Yes, Muhammad Umar, done. Not done. Are you writing, Muhammad Umar?
Yes, sir, I'm writing.
Achha.
Last point.
Okay, okay.
Done, sir.
Okay. So as you can see in this now, mainly we will be having acid or bases, right? If there is ions, that means there will be some acid and there will be some bases, or there will be some salts, acid and bases and salts. And salts are prepared by acids and bases. So more or less what we are going to talk in ionic equilibrium is just acids and bases. Okay, acids and bases, and the salts. Salts are also prepared by acids and bases. That is why we have to learn about acids and bases first. So write the topic acid-base concepts. Acid-base concepts. Acid-base concept. Okay. Now, in acid-base concept, we will be learning about the different definitions that are given by different scientists. So the first one is the Harhenius definition, or the Harhenius concept of acid-base, right here. Harhenius concept. Of acid base. It's very simple. For Harhenius, if you have an acid, then an acid, it should give H plus ion, H plus in aqueous solution, H plus in aqueous solution. For Harhenius, if you have a base, then the base should give OH negative ions in aqueous solution. Okay, in aqueous solution. So in this, you can have examples of acids such as HCl, H2SO4, HNO3, CH3OH, CH3COOH. These are the examples for acid. For base, you can have examples such as NaOH, all the hydroxides, CaOH whole twice. Then also you can have some weak one, NH4, OH, NH4OH, etc. So these are the examples for acids and bases. So simply speaking, what you can write is, if you have acid, it should be having one H ion, one H, it should be present. And if I add water to it, then it will be getting converted to H plus, and you will get a negative. We'll get a negative here. And if you have a base, then the base should be connected with OH, and this OH should be dissociated if I add it to water. So you'll get OH negative plus B positive. B positive. Now, according to Harhenius, you can write here the concept of strong acids and strong bases, right? So according to Harhenius, acids, those acids that completely dissociated, are called strong acid. Similarly, if I have base that completely dissociated, bases that completely dissociated are called strong base. If I have acid that partially or incompletely, right, partially dissociated, are called weak acids. Similarly, if I have base that partially dissociated, are called weak base. Write this down, let me know later.
Done, sir.
Is there anyone who's still writing?
So I'm writing.
Writing, okay.
Done.
Done? Muhammad Umar?
Done, sir.
Done,
Sure.
sir.
If you're done. All right, next. Bronsted-Lowry concept of acid and bases. Bronsted-Lowry. Bronsted-Lowry acid-base concept. Bronsted-Lowry acid-base concept. Now, in Bronsted-Lowry acid-base concept, this is also very simple. Rather, I would say you don't have to remember anything. What is an acid? Substance that donate H plus. And a base, what is a base? Substance that accepts H plus. Substance that accepts H plus. Now, I'm writing a reaction, okay? I'm writing a reaction here. HCl plus H2O. It is going to give me H3O positive plus Cl negative plus Cl negative. Just let me know if you're done till here. HCl plus H2O is giving you H3O plus and Cl negative.
Done, sir.
Done. All of you done? Yes or no? Tell me that first. Atif, Aisha.
No, sir.
No, Reba writing. Okay, right.
Done, sir.
Done. Okay. So substance that donate H plus and accepts H plus. Okay. So you track what is donating H plus and what is accepting H plus. Now, if I talk about this substance, you tell me it is donating H plus or it is accepting H plus in the reaction. So what you have to see, HCl, it has converted into Cl negative, right? Yes or no? Tell me, guys.
Yes, sir.
Yes, sir.
So what it is doing? What is it doing? Is it donating or is it accepting H plus ion? It is giving out H plus, or is it what has happened? H plus has been removed from it, or we have added H plus to it, guys? What happened, guys? I'm asking you a simple question. Why you are taking so much time? Yes, Reba, Mariam. क्या हुआ है HCl के साथ? We have removed H plus or we have added H plus to HCl?
Removed.
Removed. Right. We have removed it. So that means this has donated, na? HCl has donated H plus, yes or no?
Yes, sir.
So this is an acid. Now tell me about water. What has happened to water? It has accepted H plus or it has donated H plus?
It has
Accepted.
accepted H plus.
Yes, it has H plus. So I can write that H2O is a base. Any problem till here?
No, sir.
No problem. Okay. Now tell me about H3O plus. Now this reaction, I am showing that this reaction can go backwards also. Okay. Just imagine that this is happening. Okay, this is happening. H3O plus, it is what now what it is doing. H3O plus is accepting, or is it giving out in the reaction? See, it has changed to H2O now. So it is donating H plus, or is it accepting H plus?
Donating.
Donating H plus. That means what it is now? Acid.
Acid.
Acid now. But if you have acid now in the product side, you will write that as conjugate acid. This will be conjugate acid. Why? Because this is an acid of a base. This acid, it has only formed from a base. It has been formed from a base. Similarly, this Cl negative, what it is doing, it is accepting H plus if it is going from this reaction Cl negative to HCl. That is why I will say what? Here, this is conjugate base. And if I have HCl and Cl negative together are called what are they called? They are called conjugate acid base pairs. They will be called conjugate acid base pairs. Similarly, we will have H3O plus and H2O are called conjugate acid base pairs. Okay, so in one reaction, you will have two acid and two base. One acid, one base will be in reactant. The other acid, the other base will be in the product. So you will have to identify the conjugate acid base pairs. Okay, conjugate acid base pairs. Are you done, guys? Tell me.
Yes, sir.
Done. Simple concept, conjugate acid, conjugate base. You have one more question that you will do in your homework. Okay. So 3 questions directly from NCR. है ना? 37, 38, 39. इसी वजह से बहुत ज़्यादा सवाल है. Simple concepts, but you have. अच्छा, Muhammad Umar, you want me to explain this? You turn the mic on, then only I can explain. You can only answer. I can't explain anything. So, first of all, you tell me, do you have any problem in identifying what is happening to HCl and what is happening to H2O? Mohammed, you tell me that.
So I know that HCl is donating Cl.
HCl is donating what?
Cl.
No, I am asking in terms of H plus only. देखिए, तो बहुत अजीब बात हो गई ना. HCl got converted to Cl negative, yes or no?
Yes.
Yes. So what did it donate?
Yes. Donated.
Donated H plus, है ना?
Yes.
And where did that H plus go? See, whenever you are donating, it will go to someone. Na? If you are donating it, that means it donated to H2O. Yes or no?
Yes, sir.
Did H2O accept it?
Yes, sir. It accepted.
So H2O is a base, HCl is a acid. Fine.
Okay.
Okay. Now you tell me what is happening with H3O plus. H3O plus is converting to H2O. If I go from here to here, guys, what
Yes.
happened? Mohammed? If I go from here to here, backward, है ना? So H3O plus is getting converted to H2O, yes or no?
Yes, sir.
So is it donating something?
Yeah, it's donating.
What it is donating?
H plus. H plus.
So it is an acid,
Yes, it's an answer.
but it was only formed from H2O. That is why we say that it is a conjugate acid of the H2O. Okay.
Okay, sir. Okay.
Okay. So similarly for Cl negative, it is accepting one H plus. That means it is a base, and since it has been formed only from HCl, that is why we say that it is a conjugate base of HCl. It is a conjugate base of HCl. Okay. Fine.
Okay.
Yes, Muhammad Umar.
Okay, sir.
See. Let me tell you. Keep your mic on. Keep your mic on. Let us see this question, and if you do this question, you will be fine. Tell me. They have asked what are the conjugate bases for Bronsted acid HF, H2SO4, and HCO3 negative and HCO3 negative. So these are acids. So what you need to do is you need to remove the hydrogen from them. So it will be what? You remove a hydrogen. So these are acids, and these will be the conjugate bases. So from H2SO4, you remove one hydrogen, it will be HSO4 negative. Then similarly from HCO3 negative, you remove one hydrogen, this will be CO3 2 negative. Okay, then you have write the conjugate acids for the following conjugate bases. So you have to write, you have the bases here. See, what does acid do? It acid से आप क्या करते हैं? H plus, it donates H plus ना, so you just remove H plus. What does base do? It accepts H plus. Okay, and you will get the conjugate acid. What is the base? NH2 negative. Then you add H plus to it. If you're adding H plus, then it will get NH3. The negative charge will be neutralized by the H plus. Similarly, if I will have NH3, then what will happen? I will add H plus, it will become NH4 and a positive charge because it was neutral, and I'm adding a positive thing. Similarly, if I have HCOO negative, then what is going to happen? I'm adding H plus because it is a base, it accepts H plus, it will be HCOO H. Okay, so these are the conjugate acids of the following bases. Now you have this PCH2, HCO3, and can act both as Bronsted acid and both for each of the corresponding. For each case, give the corresponding conjugate acid and base. Similar, it is fine. You have H2O. If I will add H plus, if I will add H plus, what will happen? What I'm doing, I'm adding H plus. Then it's getting converted to H3, O positive. But if I am removing H plus, then it will become OH negative. Similarly, I will have HCO3 negatives. I will add H plus and it will get HC, H2CO3. I'm adding H plus. I can also remove H plus because we have one hydrogen here. So I'm removing H plus and it will become CO3 2 negative. Then we have NH3. If I will add H plus, it will become NH4 positive. If I will remove H plus, it will become NH2 positive. No, NH2 negative. Okay. So this is the whole thing about conjugate acids and conjugate bases. Write this down. Let me know if you're done. Now, since H2O, HCO3 negative, NH3, all of these can go on both the direction. They can add H plus, they can also remove H plus from them. Hence, they are also known as amphoteric. We will write that, but first of all, write these things down. So this is H2O. Now these are all what? What are these? These are the conjugate. What are these conjugate acids? Okay, these are conjugate acids of what we have here, the H2O, HCO3, and these are the conjugate bases. Okay. If I look at H2O and H3O plus, then H2O is an acid. It is adding H plus. H3O plus is a conjugate base. Sorry, H3O plus is a conjugate acid. H2O is a base. Write this down. Let me know if you're done. Done, guys?
Wait, sir.
Done, sir.
Yes, done. Muhammad Umar, Reba,
Sir,
Mariam.
can you scroll up?
Sorry, scroll up.
Yes.
Screenshot ले लीजिए, please. Muhammad Umar.
Okay, sir, done.
Done. You're done with this also, no?
Yes, I'm done.
Done. Okay, fine. Now you can write. Substances that can can add and remove H plus and act as acid in some cases and base in others. Are known as amphoteric. They are known as amphoteric. Okay. Now let's go back to the reaction in which we have HCl plus H2O giving me H3O plus Cl negative plus Cl negative. Now we know that HCl is a strong acid, and at equilibrium we will be having most of the products. We will be only having products. There will be no HCl. Okay, we will not be getting any HCl because it will be easily dissociated. It will be easily dissociated. Now, what does it say about these species? What does it say about these species? We have this is as acid, this is as base, this is conjugate acid, this is conjugate base. Now, water, we don't want to talk about water because water is the substance in which HCl shows its acidic character. I will be talking about HCl here and its conjugate base Cl negative. Now, when you have base and acid in both the cases, then the reaction can go any point. It can also go forward, it can also go backward, And it doesn't even matter if I will write it like this now. H3O plus Cl negative. And if I write it like this, then you will say, sir, now in the reactant side, we will be having at equilibrium, we will be having most of the reactant. That means H3O plus and Cl negative. We will not be having any of the product HCl. We will not be having any of the product HCl at equilibrium. Why? Because we all know that HCl is a very strong acid. It will completely dissociate itself into H plus and Cl negative. That H plus will be going and attaching itself to the H2O molecule. That's another thing. But HCl, it will get converted to H plus and Cl negative, H plus and Cl negative. Now, what does it say about the Cl negative? Now, Cl negative is also a base. Cl negative is a base. That is, it's a conjugate base, but it's a base, right? It is a base. It can add H plus. It can add H plus, but it is not adding H plus. It is not adding H plus. It is not adding H plus. It means that I can say that Cl negative has the less tendency. It has less tendency to add H plus to itself, and that is why this is a weak base. And this, what is this? HCl is a strong acid. If Cl negative was a strong base, then it would have easily added, it would have easily accepted H plus ions, and what it would have done, it would have formed HCl, but it is not happening. What is happening? HCl, it is getting dissociated into H plus and Cl negative. That means H plus has the higher tendency to give H plus ions. That is why it is a strong acid. Now we can write a relationship here. That strong acid has weak base. Strong acids, they have weak base. But what base? Weak conjugate base. And you can write strong base has weak conjugate acid, and weak acid has strong conjugate base. And then you can write weak base has strong conjugate acid. So write these 4 points. Let me know if you're done. So your homework will be okay. Yeah, just write some homework. Yeah, till 39, I think you can do. So 23 to 23 तो कर लिया ना आप लोगों ने 24 से. Start from 24. Now those will be easy. Okay, don't worry. बहुत ज़्यादा tough नहीं होगा. Like they will be easy. Not much of quadratic equation. They will be. Most of them will be. What will happen if I change the temperature, pressure, and so on? Okay, simple things. There will be some questions about the delta G, also delta H, delta G and delta H's. Those things also will be there, the relationship that we had. Okay, so fine, 27, 28, 29, 30. And till 39 you can do. 35 तक तो कर लीजिए, 36 तक नहीं 36 मत कीजिएगा बस. हाँ 35 तक हो जाएगा आप लोगों से. 24 to 35. Okay, 24 to 35. 36 नहीं करना है अभी. 37, 38, 39 तो हमने कर ही दिया है ना. चलिए. Okay then. We will meet on Monday. Okay guys. Let me know if I can stop sharing the screen.
Yes, sir.
जी. आपके कुछ बोल रहा था, बताइए. नहीं. रीबा आपको मिल गया ना PDF? Yes, Reba. Acha, I can't hear you. Acha. Also, one more thing, please do the questions. Okay. Don't give yourself excuses or any reason. You have 73 questions in equilibrium chapter in NCERT itself. Okay, in NCERT itself, and you have to complete all of those things. Okay, you have to complete all the questions. There are some very easy questions. There are some which are not tough, I would say, but those are lengthy questions. Okay, so please, rather than doing them for the first time in examination, है ना, ऐसा नहीं हो कि एग्जाम में बैठे पहली बार वो सवाल देख रहे हैं, है ना, ऐसा लगे कि एनसीईआरटी में देखा था सवाल, किया नहीं हमने अपने आलस की वजह से. So please, I just want that you don't regret in your examination hall कि हम थोड़ा सा और मेहनत कर लेते तो हो जाता, है ना. I just don't want that. So please start practicing. You have thermo also. अब तो बहुत सारे लोगों को एग्जाम के डेट्स मिल चुके हैं. Those who have got the examination date, then again you already had something to motivate you, है ना. So pressure है. So please accept that pressure and start solving the questions. I am here for you guys. ठीक है. कभी भी if you have any doubt in any question, I don't know, somebody asked from this batch. मरीम आपने पूछा था क्या कोई सवाल?
Yes, sir.
अच्छा, it was actually I did not know who was that. Okay, so you got the answer for that question?
Yes, sir.
है ना? Okay, fine. So I am there. हम जवाब दे ही देते हैं. Not if not, like I usually answer. हम ये अपना कोई ये नहीं करेंगे कि हम कल देंगे या परसों देंगे. I don't do that. I usually give answer in the same day, as soon as possible if I get any questions. Okay, so please, है ना, हम हैं यहाँ पे. If you have doubt, ask me something. If you want some sessions with you personally, you can ask Nishkar sir if that is possible. And if I will have time, actually, in the morning times now I have my research project going on. That is why it may not be possible on the same day that you ask, but I will accommodate. Okay, I will accommodate if you need some extra hours also. But you should be having doubts. As an Ionaji sir, explain me this. And please don't come up with these very vague requests. Sir, हमको ये chapter explain करते हैं. Sir, थोड़ा सा ये बता दीजिए, है ना? I don't like it. I understand where you are coming from. I was once a student. I know this, but I want ना that हम जितना मेहनत किए उससे थोड़ा सा तो आप ज़्यादा कीजिए. I'm just giving you an just pushing you guys. Whenever you have doubt in a lesson or something, try to pinpoint it, है ना? Try to pinpoint it. अगर नहीं भी हुआ, then also you can ask. Okay, I will make you pinpoint what is the problem with you. Fine, but please, I'm saying पढ़ना चालू कर दीजिए. And in 11th you get good grades. It will be really helpful in chemistry, especially if you are going in 12th standard with the same subject, that is science. Okay, maybe in physics and mathematics not much very helpful. 11th and 12th standard are very different, but in chemistry it is a continuation. Solid state nahi padha hum logon ne, but we have learned gaseous state, right? So gaseous state, liquid state, and then we again have concentration terms. Those things, all things are there in 12th standard. Okay, tell you. Now you guys can leave, do those questions, send me doubts. We will meet on Monday again. Okay, bye guys. Thank you very much. Assalamu alaikum.
Thank you.
Thank you, sir.
Bye,
Thank you,
sir.
sir.
Bye bye. Take care. Yes, Umar, you want to say something?
So I can't understand how to predict forward and backward reactions in equilibrium.
Like when it is changing?
Yes.
Okay.
I mean, how to predict the forward reaction or backward reaction.
Like the problems like QC, KC1 or the one that we did today? This one, na? Yes, Mohammed Umar. Can't hear you.
I can't see your screen.
Sorry,
I cannot see your screen, sir.
can't see my screen. Why can't you see my screen? What about now?
Yes, okay, now I can see.
Yes,
Yes,
tell
this
me.
one.
This question only, na?
Yes, sir.
Okay. No, I'm asking, first of all, you tell me this. If I will add H2, when there is equilibrium, then nothing happens, right? Yes, Umar?
Yes,
When there is equilibrium, nothing happens?
nothing happens.
Nothing happens. Okay. if I will add H2, then something will happen or nothing will happen? If I will add H2,
The number of reactants will increase.
no, that I have already added. Now you just said it in a different way. So I'm asking, in the reaction, something will happen or nothing will happen in the reaction? Actually, Umar, you are not audible if you're speaking something.
No, sir, I'm thinking the answer.
Okay. I'm not asking one more thing. I'm not saying that you tell me what will happen. I'm asking, will something happen? Yes or no? What do you think? Again, if you're speaking, then I can't hear you.
No, I'm not speaking.
Okay, now tell me. Achha, let me give you a simple example. Okay. A is in equilibrium with B. Okay, A is in equilibrium with B. And I'm saying, no, at this point of time, there will be some equilibrium constant, and that is equal to 1. Okay, the equilibrium has been achieved. I have 5 moles of A and I have 5 moles of B. Fine, Umar?
Okay.
Now, I added 2 moles of A. Okay. Okay.
Okay.
Now, do we have equilibrium or the equilibrium has been disturbed? Or do we have equilibrium? Yes or no? Just tell me that.
No, we don't have any problem.
We don't have an equilibrium. So what will happen? It will go towards equilibrium, Hannah?
Yes. Yes.
How can it do? What will it do?
By adding 2 in
By adding
B.
2. Nahi, to, can the system add on itself?
No, we have to add.
What can happen now? हम यहाँ पे कर देते हैं, थोड़ा सा बचत होगा. अच्छा, Mohammed Umar, tell me something.
Yeah.
Can I not say that now this is the initial condition? ऐसा दिखते हैं ना? We can see it like this, no? Yes or no?
Yes. Yes.
We can see it like this. Any problem?
Yes. Sir. No problem.
No problem. No? Okay. Now tell me what will happen. If I will have 7 moles of A, 5 moles of B, and the equilibrium constant is 1. That means for each mole of A, I need 1 mole of B. I know. Now tell me what will happen.
Yes.
Yes, Umar, you're thinking?
Yes, I'm thinking.
I need this. Hana, we need this, na? Mohammed Umar, you understand this? Yes or no?
Yes.
We need this.
Yes.
कैसे होगा?
5/7?
No, it should be equal to 1, na? I need the reactant and the product in such a way because the equilibrium constant is 1. Okay, only if the equilibrium constant is
either 5/5 or 7/7.
नहीं 6/6 भी तो हो सकता है. एक A जो है कन्वर्ट हो जाए B में 6/6 हो जाएगा.
Yes.
Okay.
Yes. Okay.
Think about reactions. What the system is going to do? System is going to convert 1A to B. Now both of them will be 6 and 6. है ना? That means if I added something on the reactant, the reaction went forward direction. Correct?
Yes, sir.
Now what will happen if I add something on the product? It will go towards backward direction.
Backward direction.
Got it?
Okay.
Anna, so see, now one more thing. What we did, we increased the A, yes or no?
Okay, sir.
And what did the system do? it decreased the A,
It decreased there. Okay.
है ना? So whatever we are doing,
attain
to
equilibrium.
attain equilibrium. Yeah, to attain equilibrium. So the main idea, our North Star is the equilibrium. है ना? Our North Star is we have to
And
head
sir,
towards equilibrium.
how B became 6?
Because A अच्छा A को क्या हुआ? A कैसे कम हुआ? A reacted ना, A converted to B ना?
Okay.
Reaction हो रहा भाई, ऐसे नहीं, we are adding. Got it?
Okay, sir. Okay.